Let's continue. Now the second part of the chapter is 7.2. Guys, this is a very short chapter. After I explain this stuff, I may solve some questions and share this on YouTube, okay, the problem session. And next week, Monday, we will see. We may have class or depending on the situation. All right, gradient of a straight line, another important concept, very important, but maybe now we are not going to learn in detail because it's applied a lot in physics and math and a lot of stuff. But here we are just going to learn again some basic idea about this. When you walk or ride a bicycle up a hill, the hill will undoubtedly slow you down, right? The steeper the hill, the harder it is to climb. We call the measure of the steepness of a hill the gradient or slope. This is the ratio of the vertical distance, the rise to the horizontal distance. That is the run. And this is how we define the gradient. Yeah. How can I change this every time they enter? Click one by one.
How's your syllabus? Syllabus. I don't know if we need to match against any of the PLOs. What's a PLO? Program Learning Outcome. Yeah. And which PLO, right? Because there's one for civil engineering, one for whatever engineering.
Yeah.
I don't know what.
Yeah, I think we should prepare something different. I don't think we have to follow because math, everything is clear, what we have to teach. It's not like engineering or architecture course.
Really, we should have our own PLOs.
Yeah, that's right. Okay, so video security, participants. Okay, people are joining, keep joining. So here we are given two hills, the first one and the second one. Okay, simply as you see here, I just like from front, right, and this road, it looks like a straight line, and also it looks like a straight line, right? And from here we can see that riding a bike on this road is easier than riding a bike on this road, right? Because here you don't have to use a lot of force to ride a bike on this road. Why? Because this road is steeper than this, right? So actually, how to say that this road is steeper than this, and by how much? In math, actually, we just introduced one concept to measure the steepness of a road or line segment. We call this gradient. Okay, how steep the road is or how steep the line is. So we call this gradient. How do you measure this? It is just the ratio of the vertical distance, this vertical distance to the horizontal distance, And it gives us the idea about or information about the steepness of the road. Then I can compare. If the gradient is higher, it means that the road is steeper, right? So here, rise over run, the difference in y coordinates between any 2 points, here, and the difference in the corresponding x coordinates. Here we have, actually, if I just draw this, 2 coordinates, right? And I can measure it is, what is it? Here, if I draw one horizontal line and one vertical line, for example, and here the difference, right? That one is usually, let's say this delta y, and this difference is delta x. All right, the ratio, the delta y over delta x. What do we mean by delta y? It is y2 minus y1 difference over x2 minus x1. And we call this the gradient of this road or line segment. Usually we use here m. Okay. So in general, let's say if you're given 2 points, okay. Let's say the coordinates of the first point, it is x sub 1 and y sub 1. We are talking about this point. And the second point, let's say here it is, this one should be A, and this one should be B, right? Whose coordinates are x sub 2, y sub 2. All right. And how do you find it is gradient? How steep the line is? To do this one, usually we are just defining this formula. That is y2 minus y1 over x2 minus x1. It gives us the slope of this line or gradient of this line segment. Okay, or if you just multiply numerator and denominator by -1, nothing changed. Here we get either y1 minus y2 over x1 minus x2, or use this formula to evaluate the gradient of a straight line or line segment. Now here in this example, as you see here, if the line is horizontal line, right? Horizontal line, that means that y coordinates are not changing. Horizontal line means y coordinates everywhere the same. So that means a 0 over something is equal to 0. So horizontal line slope is 0. Right? That's why walking on the horizontal line is way easier than walking on a road which has a slope something different from 0. And this line, for example, slope is 1 over 5, right? And this line, let's say slope is 1 over 2. And this line, it is 1. 1 means that angle is 45 degrees, right? And as you see here, as the slopes is increasing, right? And also the steepness of these lines are increasing. And how about the vertical line? Vertical line means, actually here, x coordinates are not changing, right? Vertical line. And here, this point and this point, it is x coordinates are the same. And that's why it is 0. If you divide something by 0, actually we don't have 0 division. It's very slow, it goes to infinity here. Actually, this we don't say infinity, but here it's undefined slope or infinity slope. Okay, so vertical line slope is infinity or undefined, and horizontal line slope is 0. And other just change between the 0 and this infinity. Okay, all right. We have 2 examples here and 1 example from exercise 7b. That much is enough. These are very basic and simple ideas. Find the gradient of the line joining the points. Now I don't want to draw this line. First, let's calculate this. After that, we can draw this. Otherwise, our drawing may be wrong. So in question A, we are given 2 points, right? A, it is 2, 3, and B, 7, 5. So how do you evaluate the gradient of the line segments or line that passes through these 2 points? Just using the formula, it is y sub 1 minus y sub 2, corresponding axis x sub 1 minus x sub 2. And let's say this one is x1, y1, and this one is x2, y2. So 2, here we have first y, right? 3 minus 5. So here we have 3 minus 5 over 2 minus 7. 2 minus 7, which is equal to, here we have -2 over -5. Or that's equal to 2 over 5, right? Now, if you just look at the previous slide, 2 over 5, where is it? 0.4, it is something like this, right? Here. So it is between 0.2 and 0.5. So our line is, if this is our coordinate system, right? Our line is something like this. Maybe it's passing through the origin, or it doesn't have to pass through the origin. It is something like this. So this is our A, and this is our B, and this is our A, and this is our B. Okay. All right. In example B, so gradient of APQ equals 8 minus 1, 8 minus 1, y1 minus y2 over x1 -2 minus x2. It is 1. just 1. Which is equal to, here we have 9 over -3. That's equal to -3. Okay. And what does negative mean? Negative means our line is something like this. Okay. And this one is increasing, this one is falling down. So the gradient of this line is m is equal to -3. Okay, it's a vertical line. One, it passes this vertical line. Now it is, what is it? Negative number. Negative number means the line is falling down, right? And positive means it is moving or just rising. Okay. So one example, this is a very important example. It's a kind of basic idea to write the equation of a straight line. That's why I put it here. The points 2, -3, 3, -2, and 8k lie on a straight line. Find the value of k. Okay, so we are given this kind of straight line. Okay, so here, let's say this one is A, whose coordinates are 2, -3, and here we have, let's say, B, whose coordinates are 3, -2, and this one is C, whose coordinates are 8k. Okay. So the question is saying that they are lying on a straight line, and we need to find the value of k. And every line has a single slope. Every straight line has only one slope or one gradient. Okay, it doesn't matter actually to calculate this gradient. You are picking these 2 points or these 2 points B and C or A and C. Doesn't matter. It gives us the same result, the same slope. Using this very important idea, I will just use this equation. Gradient of AB is equal to gradient of BC, right? Because after all, they are representing the same line, or they are lying on the same straight line. Okay, so this is very important fact. So what is the gradient of AB? It is -2 here, or -3. Here we have -3 minus y2, -2 over 2 minus x2, it is 3, equals, how about the gradient of BC? It is k minus -2 over 8 minus 3. Okay, and that is really important. Now, by just solving this equation, as you see here, we have equation, one variable unknown. We can solve this, and we can get the value of k. If you just simplify the right-hand side, k minus -2, so here we have k plus 2 over 8 minus 3 is equal to 5, equals -3 plus 2, -1 over 2 minus 3, it is -1. And -1 over -1 is equal to 1. So from here, k plus 2 is equal to 5, dot, dot, dot. Then what is the value of k? Is equal to 3. Shantara, are you there?
Yes, sir. I'm always here.
Very good. Shantara, I think everything is clear. If you have any questions, guys, you can ask, or we can ask later, we can discuss, because now I'm just trying to explain. And if you have any questions, you can either ask your assistant teacher, or you can ask me directly. And also, I'm going to solve some important questions and share on YouTube. Okay, guys, that's all about finding the distance between 2 points and how to evaluate the slope of a straight line. Okay, so we will finish this by this quote: success is neither magical nor mysterious. Success is a natural consequence of consistently applying basic fundamentals. Actually, these quotes, I'm just searching in the Google, and when I like some quotes and sharing with you here. And some quotes is really, how to say, they have very deep meaning, and you need to just sit and think and maybe discuss, then we may understand something. All right. So this is also one of my favorite quotes. That's why I'm sharing this with you here. Guys, that's all about the distance between 2 points and how to find the slope or gradient of a straight line. Now we will talk about the equation of a straight line. I'm closing this session, this slides. All right, give me a minute. Okay, I will finish the class at 11:45. What time is it? 28. We have 17 minutes left. Okay, guys, just give me 1 minute, 1 minute break. After 1 minute, we will continue with the third part of this chapter, the equation of a straight line. 1 minute break. Is this really hot, man?
Yeah. What's hot, is it, these days?
Yeah, very hot.
Yeah.
Because now without aircon, we cannot sleep. Usually we sleep without aircon, but now this is the
No,
last
now,
20 days.
the last month.
All right, I'm back. Okay, guys, equation of a straight line. So the main idea is there are some different forms of equation of a straight line. Okay, but here just if we need to try to get one equation and using this one by doing some algebraic manipulation, we can get the other forms of this equation of a straight line. Okay. Now this is our coordinate system. This is a y-axis and this is x-axis. Assume that we are given a straight line. So this is our straight line. Let me just name this one L. Okay, line L. Okay, and also assume that we are given 2 points lying on the line. Let's say this point is A and let's say this point is B. This is given, okay? And let's say coordinates of A, it is x1, y sub 1, and coordinates of B, x sub 2, y sub 2, okay? Now the question is, okay, if we are given a straight line and we know these 2 points, how do you write the equation of the straight line? Okay, what does it mean? It means that writing the equation of straight line means we need to write an equation here. Actually, the general form is like this: ax plus by okay, and plus, or maybe is equal to c is equal to 0. That is the general form of the equation of a straight line. Okay. Now we are trying to get this equation, or another form also. We are going to see this soon. Okay. So why do you need this equation? Okay. If this line is representing something, all right. If I can get the equation of the straight line, okay. Actually, by using this equation, I can evaluate the value of x or y anywhere on this line. For example, if you just give me, for example, x, okay, here, x is, for example, let's say this 2. H2, what is the value of y? Here, right? So by substituting here, we can evaluate the value of y. Okay, and usually when I just write this equation in this form, y equals mx plus c, actually this gives us a linear equation or linear function. Okay, so if I have this equation for every value of this input or input value of x, okay, I can evaluate the value of y. And without this equation, how can we determine this? For example, let's say when x equals 2, what is the value of y, right? And you need to just find this point and look for y. At the time, we can determine this. And once we have this equation, we don't have to think about this one, right? I can get all the information about all the points in this line. For example, when x equals 2, what is y? Since I have the equation, I can get this. When x equals 3, what is y, for example? I can make a table. Okay, and of course, we are not going to learn this in detail, but this linear function is used a lot in daily or practical situations. Like, for example, taximeter, if you are taking a taxi, right, they are calculating, for example, if you travel for 7 kilometers, how much do they charge and how they are calculating this using this linear function. Or if you are paying tax, for example, let's say if you're doing some kind of business or if you have any kind of income, you need to pay tax to the government, right? And you pay tax to the government depending on your income, right? The more income you have, the more tax you pay. And also when they're calculating tax, they are using this linear function. Okay, and also your electricity bills, they use linear function. All those stuff. These are just some examples, but here we are not going to see this. Okay, I'm just going to give you some basic idea about the equation of a straight line. Anyway, let's get back to this problem. So if you're given a straight line, if you're given 2 points, how do I write the equation, okay, of this straight line? So actually, I'll use the idea that we did in the previous example. Let me just denote this one as x. Okay, the point x. What is x? Is any point on the number line. That means it's just representing any point on the line whose coordinates are x and the y. Okay, it can be this point, it can be this point, it can be this point, anything. So now my task is I'm going to write this equation because I'm going to find the connection, relation between this x and y, how they are related to each other. Okay. To do this one, since all these 3 points now lying on the same straight line, so I will use this idea. The gradient of AX must be equal to gradient of AB. That is simple, but very important idea. I mean, fact. Okay, because since all these points are on the same straight line, even if you just pick these 2 points and evaluate the gradient, or these 2 points, X and B, evaluate the gradient, or these 2 points A and B, evaluate the gradient, they produce the same result because they give a single slope. Why? Because every straight line has a single slope, one slope, okay, unique. It doesn't have 2 different slopes. Anyway, using this idea, we know how to find is evaluate this, right? How to evaluate this, that's equal to y minus y1, right, over x minus x1. Y minus y1 over x minus x1. On the right hand side, gradient of AB. And we have already learned how to calculate this. That's equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Actually, that gives us the first form of the equation of a straight line. And we call this 2 points form of the equation of a straight line. Why? Because 2 points are given, so that using this, I can write the equation of the straight line. And after that, I know this x to x1, y to y1, and I can simplify this. It gives us a single number. Take x minus x1 to the right-hand side, and I can simplify this. Okay. Now the second form. Okay. So assume that we know that this is a gradient, right? It's a gradient of, what is the gradient of the straight line? That's equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If I substitute here, what we get here, y minus y sub 1 over x minus x sub 1 is equal to m. And this is another form of the equation of a straight line. And we call this a point and gradient or slope. When one point, if you're given like this, okay, and I know the coordinates of this point, let's say this x sub 1, y sub 1, and I know the gradient of this line, m, then also I can write the equation of the straight line. Why? Because this point, a line passes through this point and having this slope, that line is unique. Okay, the only one line has this property. You cannot show two different lines and having this property. It's not possible. It's only one unique line. Okay, this is another form. And if I just go further, number 3, for example, gradient form, or gradient and y-intercept, or just gradient form. Now, if I take this to the left, to the right-hand side, what we have here? Y minus y1 equals mx minus x1. Right? Or if I just do some algebraic manipulation, y equals, here we have mx minus mx sub 1, and also y1 take to the right hand side, plus y1. Okay, and this m is given number, I know, x1 is given number, y1 is given number, and evaluate this all together and simplify, it gives us given number. And let me just label this with c, okay? Then our equation becomes, what is it? Y equals mx plus c. And this is gradient form of the equation of a straight line. As you see here, what is this m? It's the gradient, right? And what is c? It is y-intercept, because if x equals 0, the c gives us y-intercept, where the line crosses the y-axis. Okay, see here, once we get this one, just doing some algebraic manipulation, we can get other forms of the equation of a straight line. And we already got 3 of them, right? Number 1 is this 2-point equation, and second one is 1 point and gradient, and third one is gradient and intercept. Okay, and also actually I can write another one. For example, let's say this line is crossing the x-axis here. A, we call this x-intercept, and this one is y-intercept, and y-intercept is B. Okay, and let's say since it is x-intercept, right? X value is A. How about y coordinates? 10 minutes left. It is 0. And how about this one? It is x coordinate is 0 and y coordinate something. Let's say it is B. Right? Now this one is number 4, I guess. How can I write the equation of this one? Using the gradients. Okay, this one is y minus y1. It is 0. Over x minus a is equal to b minus 0 gradient over 0 minus a. 0 minus a. Now if you simplify this, what we have here, y is equal to minus b over a times x minus a, right? Or remove the brackets, here we have minus b over ax plus a cancels here, b. Okay, let me just take it to the left hand side. Then we will have here b over a times x plus y is equal to b. Now if I divide both sides by b cancel each other or multiply by 1 over b. So here we have x over a plus divided by b, here we have y over b. Divide this by b, here we have 1. And here we have intercept form. We got another form of the equation of the straight line. As see here, if it is given in this form, that means that immediately I can read it as, this line is crossing the x-axis at point A. It is crossing the y-axis at B. If it is in this form, make sure that here we have 1. Okay, these are some different forms of the, equation of a straight line. How about the general form? General form is, here we have ax plus by and equals c, or simply I can just write it as plus c is equal to 0. And this is the general form. Okay, how can I write the general form? Again, using this one, y minus y1 over x minus x1 is equal to, here we have, let's say, m, right? And here we have y equals mx minus mx1 plus, plus y1. Or if I just take everything to the left hand side, mx, or take to the right hand side, minus y minus mx1 plus y1 is equal to 0. Okay. Now I can just relabel this. Let me just relabel this one as A, and this one is as B, and this one is as C, for example. These are all constants, right? And we get this equation. Okay. And because that means that every straight line, as a conclusion, we can say that either it can write in this form, or it can be written in this form, or it can be written in this form, or it can be written in this form. Or if you are given any equation in this form, or this form, or this form, any of these these forms, actually, they specify or they define a straight line. Okay. We have 6 minutes left. Let's solve 2 examples and I will finish the class. Example 5. Given that y equals 3x plus c passes through the point A, 3, 1. Find the value of c. That means that we are given a straight line here, right? And here we have A and 3, 1, right? And the equation of the straight line is y is equal to 3x plus c. And what is the value of c? Since this point belongs to this line, right, and this is the equation of the straight line, when I substitute here, it must satisfy this equation. And if you substitute here, what is y? Y equals 1. 3 times, what is x? X equals 3 plus c. From here, what is c? C equals 1 minus 9, negative 8. So 8, c must be negative 8. Another example, find the equation of the straight line passing through the points. A. Actually, 2 points are given, so we will use our first equation. And assuming that this one is x1, y1, and this one is x2, y2. So here we have y minus y1, it is 2, over x minus x1 is equal to 1. And here we have y2 minus y1, 7 minus 2, 7 minus 2, over 3 minus 1. That's the equation. Now we have to simplify this. Y minus 2 equals 7 minus 2. It is 5. 5 x minus 1. So y minus 2 over x minus 1 equals 5 over 2. If you just cross multiply, let me just write this in the general form. 2y minus 4 is equal to 5x minus 5. Or 5x minus 2y minus 1 is equal to 0. That is the equation of the straight line. It doesn't mention anything, right? Write this in the gradient form or intercept form. So if it does not mention anything, always leave your answer in general form. B, To do this one, first let's find the gradient. Here we have 2, 3, 7, 3. But if you notice here, the 3 and 3, y coordinates are the same, right? And y coordinates are the same means, what is it? Here 3, we are talking about this line. That is x, and this one is y, and this point is, what is it? It is 3. Because here 2, 3, 7, 3, y coordinates are not changing. What does it mean? It means it's a horizontal line. And if you remember, if it is horizontal line, what is the gradient of this horizontal line? It is 0. Now, if you just write a point and gradient form, so here we have y minus y1, it is 3, over x minus 2 is equal to, we have m here, that's equal to 0. Or here we have y minus 3 is equal to 0. That is the equation of this horizontal line. Because it means that whatever x is, y is equal to 3. Okay? And in math, we call this a constant function. Because input value, it doesn't matter, whatever you just input here, the function produces 3, constant function. And how about question C? If you notice here, 5, 5, here x coordinates are the same, right? It is 5, 1, and 5, 6. So here we have this case. It is x and y. So here we have, this one is 5. Okay. So here, always x coordinates are the same, right? And it's a vertical line. If you remember, what is the gradient of this one? And gradient of this one is undefined. And what is the equation of this vertical line? As simply is equal to y minus 5 is equal to 0. That is the equation of this straight line. Because x equals 5, whatever y is, because y doesn't appear in the equation. Okay? Guys, others are from exercise. That many examples enough, okay? So examples from exercise, I will solve it and share this on YouTube. You can study them, okay? And that much is enough for this chapter. Next Tuesday, you will have midterm from chapter 4, 5, 6. Okay, 4, 5, 6, 7. 4 chapters. And you have to study, and there will be around 20 or 25 questions. Okay? If you have more questions, please, you can share this on Telegram. That's all for today. Thank you very much. Bye-bye.